the solution question is here you see first solve the following transportation problem, and here demand and supply, here you see demand and supplies are equal, right? So this is the balanced transportation problem, right? So first you will solve it by what? Vogel's approximation method. So up to Vogel's approximation method, all of you have solved. No? Vogel's approximation method.
Yes, sir.
Okay. So Vogel's, after solving this, then you will get solution is Vogel's approximation method. Total transportation cost is here 80. Next, what we do, we check whether this transportation cost is optimal or not. So this is solved by what? This is solved by Modi method, right? So what are the steps? First, what we do? First, we determine UI and Vj for each occupied cell. UI and Vj calculate from occupied cell. Occupied cell means where allocations are given. Okay, so here you see next one, UI and Vj. From UI and Vj, are anyone, either U1, U2, U3 or U4, or V1, V2, V4, V1, V2, V3 equal to 0. So this is depends on what? This is depends upon maximum number of allocation present in which row or column. Suppose here you see row number 4 means in U4 number of allocation is 3. Allocation is 3. So we consider U4 equal to 0, right? So if we consider U4 equal to 0, with the help of the relation Cij equal to Ui plus Vj, we calculate all values of Ui and Vj. So you see this is correct or not? All of you understood this one?
Yes, sir.
So okay. So in your exam, you will not write step 1, step 2, then you will not write cell evaluation UI plus Vj for each occupied cell and enter at the upper right corner. This is just for your understanding, right? So you can not write this language also. There will be some extra time. So just you find out U1, U2, U3, U4, V1, V2, V3, V4. Then you move to the next table. Table here 11.13. Right? So next table here, what is the rule? Next step is what? You see step number 3 written what? Then we find cell evaluation UI plus Vj. Right? For each occupied cell. Right, each occupied cell Ij and enter at the upper right corner of the corresponding unoccupied cell. Each unoccupied cell, yes, not occupied. Each unoccupied cell and enter this. So here you see which one is the unoccupied cell. You see from the table. You see cell number 1, 2. Where cost is given 7, cell number 1, 2 means first row, second column. So this is unoccupied cell. So here you write the what? Ui plus Vj in the upper right corner. So here U1 is value we already got here 1. So 1 and here V2. Ui plus Vj. So column is V2. So here U1. So U1 plus V2 will be what? 1 plus 6, 7. Right? Similarly, next unoccupied cell is cell number 1, 3, where cost is 4. Right? So where cost is 4, here also you write. So here Ui plus Vj will be what? What is Ui plus Vj? 3 because 1 plus 2 because
UI means here U1 and V3. So this one will be 2 plus 1 is 3. So similarly, then next unoccupied cell you write 1 minus 1 is 0. Next unoccupied cell is minus 1, then plus 6 is 5. Next occupied cell you move to what? Cell number. It was 6 number because after that. So next one is minus 2, 1, plus 1, so minus 1. So in this way we find out all UI plus Vj, right? So next what is your aim? Next your aim is find out the value of Dij. So how to find out the value of Dij? You write here Dij will be formula will be Cij minus Ui plus Vj, right? Cij means cost of that cell, right? So we calculate Dij in all unoccupied cell and you write Dij in the what? Lower right corner. Dij you put at the lower right corner. So here you see 7 minus 7 is 0, then 4 minus 3 is 4 minus 3 is 1. Next we move to cell number 2, 1 means 3 minus 0 is 0, 3.
Then 3 minus 5 is minus 2. Then next one will be 5 minus minus 1 is 6. Next cell number 337 minus 0 is 7. Okay. Next you see all Dij's are positive or equal to 0 or less than 0. Here you see. So here you see minus 2. One Dij is minus 2, negative value. One Dij value is negative, right? So we cannot get an optimal solution, right? For the cell evaluation, this is D what? D22, second row, second column. So D22 value is minus 2 less than 0. So we cannot get an optimal solution. Next, what is our aim? Our aim to remove this minus 2. Right. So remove this minus 2. So what is our aim? From this minus 2, we make one loop. From this minus 2 you consider one point or vertex, and from this vertex minus 2 you make one loop and try to this minus 2 you consider this minus 2, remove this minus 2, right? So when you consider this one minus 2, then you move to right hand side or left hand side or upward or downward. So which side you move? Where allocations are present in minus 2 is right hand side is in right hand side cell and left hand side cell. Where allocation present? Anyone? From minus 2 is cell number 2, 2. So here we move in such a way that where allocation are present. So right hand side cell means cell number 2, 3. It is 2, 1. Or upward cell is cell number 1, 2. And downward cell is this one. So which side we move? Where allocation is present, right? So here allocation present in where you see cell. Yes, the function. Yes.
2, 2.
Yes. Here you see either we can move right hand side or
downward. You see allocation present. Right hand side is allocation is 8. Right? right hand side allocation is 8, or from downward cell you see one allocation is 7, another next downward is allocation is 2. So you move either right hand side or downward side. So just you move, and you can move either horizontally or vertically, not in the cross way. So horizontally and vertically we move in this way. Just we consider we move from 2 to right hand side where allocation present 8. Then you move downward, and here you see in cell number 33 there is no allocation. Cell number 33 no allocation. Cell number 4,3 allocation present 10. So we move 10 in where allocation present 10 present in cell number 4,3, and 4,3 to again move left hand side. You see allocation present in cell number 4,2. Here 2 present, allocation is 2. And again you move upward side, and here again this one coincide with minus. So you see, move in this way we form a loop. You see the table number 11.1 or 14. You see, loop in this way we move, arrow symbol given. From right hand side in 8, next we move to downward cell where allocation present 10, and next left hand side where allocation present 2, and next again move to here minus 2 where present. So then this form a row. Starting and ending points are same. Then this is called the loop. So you see this is clear or not?
So what is a +2 -2 in the cell?
Yes, I shall tell this one when we use. Up to this clear formation of loop.
Yes, sir.
Yes, sir.
So the loop can also be like counterclockwise, right? Like currently is going towards the right. Can we also like go towards the like down, then
Yes. Yes, we can move in this way, downward. Downward way you move. But here you see where allocation present, then you stop. Otherwise you cannot stop. So one thing everyone see, another way, from -1 to downward cell, you see 7 is allocation. So in 7 we can stop, but here we cannot. Suppose someone may ask question, in 7 also we can stop, but in 7 we cannot stop. Why? From 7 present in cell number 3,2. So from 7 in cell number 3,2, right hand cell and left hand cell there is no allocation. So we cannot stop in 7. So we cross this 7 and move to 2. So in this way we move to cell number 4,2. So you can make a loop in this way, from -2 starting, again downward cell where allocation present 2, again right hand side you move, otherwise not form a loop. Where allocation present 10, you can move from 10 to 8, again move, and 8 to 2 again move, then this is a loop. In this way you can.
So like will we always get a loop, or like sometimes like we won't get a loop? Like how is
This is not clear, what?
so I'm saying like will we always like have a loop in the cells, or like sometimes like there won't be any loop?
Okay, text the message. Yes. Always this form a loop, where for removing this one, for removing negative dij value, remove dij, always we form a loop. Otherwise we cannot solve this one. So question will be like this. Okay, we will form a, we cannot solve this. Because another one we will see dependent and independent position I have given. How to consider this is dependent or independent. Okay, so always form a loop, otherwise you cannot solve. And loop is formed for independent positive allocation. Right? Loop is formed in independent positive allocation. Closed circuit for this is the non-independent. So you will see this is Dij for removing Dij. Always what we do, we make a loop and then we try to remove negative Dij. Negative, then we cannot get an optimal solution. Right? So for removing Dij, we always make a loop. Clear, Albert? Clear, everyone? Yes, sir. What we do? In this allocation, okay, in this allocation, what are the allocation? In the corner point of this, in the corner point of this loop, what are the allocation? Allocations are what? In the corner point, what are the allocation? Eight, then
12.
You are after this setting, no, you see 8, then you see allocation is 10.
10.
2, 8, 10, 2, right? 8,
Yes.
10, 2. So our aim is what? We eliminate minus 2, right? Minus 2 is not allocation, this is Dij value, right? So you see what we do. Here 8, 10, 2. Here which one is the smallest allocation? Which one is the smallest value? 2. So what we do, these two you add means here in all allocation in Dij you add negative Dij minus 2. You add minus 2 plus 2. Right? So what is the value? Minus 2 plus, not minus 2. This is no, minus 2 is not the allocation. Here you see, you give here plus 2 squared. You give plus 2 in negative Dij. You give the allocation plus 2 in negative Dij. Then just alternately remember this is plus 2 here allocation. Right? Next, here what we do, plus 2. So alternate plus minus, we should give this one, alternate plus minus. So plus 2 we give in cell number 2. This is the allocation, you will remember. Plus 2 we shall give the allocation. Next, in 8, in allocation 8, we give minus 2. So in 8 minus 2. So 8 minus 2 is 6. So in the next table this one will be 6. So next in 10 you give plus. So plus 2. So 10 plus 2 is what? 12. And next here minus 2. So 2 minus 2 is what? 0. There is no allocation. So you see this one. You give the allocation. You give here for removing Dij, you give positive means what? The smallest, here smallest value of this allocation. You give the smallest value. So here allocations
are 8, 10, 2. We give allocation 2, right? When we give 2, then alternate plus minus in the corner of the loop. So 8 minus 2, 10 plus 2, 2 minus 2. So this line is clear or not, you see? In cell number 2, 2, when we give plus 2, then plus 2 and minus 2, 0. Cell number 2, 2. Because minus 2 is not an allocation. Minus 2 is not an allocation. So, plus is. Here you see, minus 2, here we give plus 2. So you will not confuse. When we give plus 2, then minus 2 plus 2 is 0. Because minus 2 is not an allocation. Minus 2 is a the 2 is a what? Minus 2 is Dij value. So just we removing minus 2, we give here allocation. So here 2, then minus 2 will be given where allocation 8 is present. So minus 2, 8 minus 2 is 6, right? Then 10 plus 2 is 12, then 2 minus 2 is 0. So when we give this, then after this you see the table. After this you see the table. So you see new table is table number 11.15. You see the table number 11.15. Here ultimately what we get? 2, 5. 2 is the cost, 5 is the allocation. Then just you write the cost. First you write the cost, right? And here allocations also you put the allocation. Vj you will not write in the next table, right? Ui plus Vj is why we have written. We have written for just finding out the value of Dij, right? So here we eliminate negative Dij. Then we get again one table, right? Again you do what? Again you do optimality test using Modi method. Find out directly, return the next table, table number 11.16, but you will find out the all value of U1, U2, U3, U4, V1, V2, V3, V4 by Modi method. Then you will say you will get the here positive Dij, right? So you will get strictly greater than 0. Dij value is strictly greater than 0, then we get an optimal and unique solution. Therefore, you see, same way earlier, from source 1 transport 5 units to destination 1, source 2 transport 2 and 6 units to destination 2 and 3 respectively. Then source 3 transport 7 units to destination 2 and 4 transport 2 and 12 units to destination 1 and 3 respectively, and total transportation cost you see here we get 76. Earlier we get Vogel's approximation, first table gives us 80, right? So after optimality test we get 76. So you see this is clear or not? Here one confusion here, when negative Dij value, then how to remove? Roshni, Arbaz,